Hello and welcome to this demonstration of a full-wave bridge rectifier. In this video, I will show you how the circuit works in 3 steps. First, we will look at the basic full-wave bridge rectifier. Then we will add a filter to smooth the output. Finally, we will include a voltage regulator to keep the output stable. So let's begin. So here we have a full-wave bridge rectifier circuit. It uses 4 diodes in a bridge shape to convert AC into DC voltage. So the diodes only allow the current to flow in one direction. So the AC signal is turned into the DC signal, but it still has some ripple or peaks. So beside there is 4 diodes in the circuit. There is also have a 1 kilo ohm resistor, 2 oscilloscope, and the oscilloscope have time per division with 10 millisecond. And then here got 2 multimeter and 1 function generator. The function generator have 50 Hz frequency, 10 volt amplitude, 0 volt DC offset, and the graph is shown in sine function. After stimulate the circuit, this is the output voltage we get after the rectifier. So the graph shows a series of peaks, meaning the voltage goes up and down in a pattern. These peaks represent the pulsating DC. It's DC voltage, but it is not smooth. So during both the positive and the negative parts of the AC signal, 2 diodes conduct at a time, allowing current to flow in one direction, which gives this pulsating DC output. In positive cycle, diode 2 and diode 3 is forward bias, while diode 1 and diode 4 is reverse bias. In negative cycle, diode 1 and diode 4 is forward bias, while diode 2 and diode 3 is reverse bias. So as you can see, the voltage goes up, then drop, and goes up again. It is not a steady, smooth DC voltage yet. So this is the result of the full-wave bridge rectifier. So now let's add a filter capacitor across the output. Here is the capacitor. The capacitor helps move out the ripples in the pulsating DC. It works by charging up when the voltage is high and discharging when the voltage drops, filling in the gaps. So this makes the output more stable. And here we use a 25 microfarad of this capacitor. So after we stimulate the circuit, here's the new output with the capacitor added. As you can see, the peaks here are still there, but the voltage is much smoother. The capacitor reduces the size of the ripples, so the voltage doesn't drop as much between peaks, making the output more like a steady DC voltage, although it is still not perfect. So you can see that the voltage now stays closer to the peak value with smaller fluctuations. So this is the effect of the filter. It reduces the ripple in the output, providing a smoother DC voltage. Finally, let's add a voltage regulator. A voltage regulator keeps the output voltage constant, no matter how much the input voltage changes. This is important if you want a steady power supply for electronic devices. The regulator makes sure the voltage stays at specific value. Hence, we use Zener diode as the voltage regulator in our circuit. To achieve the regulation of voltage, we connected the Zener diode in reverse bias and set the Zener voltage to 1 volt. Since 2.19 volt, which is our VTH, is bigger than 1 volt, the Zener diode is operating in its breakdown region and voltage is regulated to 1.08 volt. So after stimulation, with the voltage regulator in place, the output voltage becomes almost flat. The voltage no longer fluctuates, it stays at a steady level, regardless of changes in input voltage. As you can see in the graph, the voltage stays at the same level. This flat line indicates that the function of voltage regulator, keeping the output voltage stable and reliable. This is the final, smooth and steady DC voltage we need for most electronic applications. So, to summarize, in this video, we first demonstrated the basic full-wave bridge rectifier which gives us a pulsating DC. And then, we added a filter capacitor to smooth the output, reducing the ripples. Finally, we include a voltage regulator which gave us a steady, flat output voltage. This setup is commonly used in power supplies to provide reliable DC voltage. Thank you for watching.